The power of our sun. This is the actual face of the sun. It is turbulent and boiling. Never the same from one second to the next, the surface bubbles like a giant bowl of porridge. Each bubble is 1,000 miles across. The heat and light brought to the surface raises its temperature to 6,000 degrees centigrade, enough to vaporize solid rock. And the sun is huge. You could fit the Earth inside it 1,000,000 times over. Periodically, huge explosions rip through the surface, releasing the energy of 1 billion atomic bombs in seconds. All this is on the surface. To understand the sun, we must know what is going on deep inside. That is where the power is generated. So for centuries, scientists have been devising ways to probe the heart of the sun. Some of them have been complex, and some of them very simple. And the first step is to figure out just how powerful the sun is.
It's easy to appreciate the power of the sun on a nice hot summer's day like here in the Texas Gulf Coast, and you can feel the power of the sun in your skin, sunscreen's on, but man, the sun is just, you know, the actual physics of what's going on inside the sun, the power that the sun, the energy that the sun is releasing is almost beyond comprehension.
But it is only almost beyond comprehension. And you can measure its power output with some simple apparatus.
One of the earliest experiments to try and measure the actual power of the sun was by astronomer William Herschel in the 19th century, where he had the brilliant idea of just watching a piece of ice melt to see how long it would take, and therefore from the properties of the ice work out how much sunlight was coming to the ground.
As a demonstration of the sun's power, it doesn't look that impressive. But Herschel realized that he could use the time it takes to melt one bit of ice to calculate the sun's total power output.
So here we see the ice is almost completely melted, roughly 29 minutes, almost half an hour. But Herschel was able to use this experiment and the time that it took to melt the ice to work out some basic properties of the sun.
Here's how Herschel's thinking worked. In the time it takes to melt a slab of ice on Earth, the sun is radiating heat in all directions, enough to melt a complete shell of ice around it, a diameter of 300 million kilometers. A shell half a centimeter thick and 300 million kilometers across contains a lot of ice, enough to make an ice cube bigger than the Earth. To melt that much ice in just 30 minutes would take an energy input of 1 billion watts. It's a rough but surprisingly accurate experiment. Modern satellite readings confirm the figures to within a few percent. It's an almost unimaginable amount of energy. If we could harness the sun's power output for a single second, it would satisfy the world's energy demands for the next 1,000,000 years.